All right, we're going to get started. Good morning. My name is Juan Natera, and I'm going to be talking about a custom Facebook integration. This is my first YAPC, so I'm pretty excited about that. All right, so before going any further, just want to let you know that this stuff that we're going to see was the work of a lot of people. These are just some of the names of the engineers, QA engineers, product persons, program management that were involved in developing this project. So just want to give a nod to them. Also, I wanted to introduce me. I've been using Pro since 2000. I'm currently working at Ticketmaster as a lead engineer. And I'm a member of Los Angeles ProMongers. Formerly, I was a member of Caracas PM, which is in Venezuela, South America. Okay. So I assume that all of you are here because there weren't any seats left at the jQuery talk. So thank you for coming, and I'll try to make it worth it. So I'll give you a quick introduction to jQuery, and that's just kidding. Okay. This is actually what we're going to be talking about. We're going to be, I'll quickly touch on Facebook Graph, which is the library that we use to integrate with Facebook. I'll give you an overview of the different components of our integration, and show you some of the actual the integration live at Ticketmaster.com. Finally, next I'll be talking about the problems we faced and how we solved them. So that's basically it. I actually don't know if I have enough material to cover the 50 minutes of the talk, but hopefully it will be enough. Okay. So Facebook Graph. It's the library that, like I mentioned, we used. It's Moose-based. It's very easy to extend. It was created by J.T. Smith, which, as some of you might know, is the YAPC 2012 organizer here in North America. Okay, there are a couple of, he actually created a couple of tutorials, and they're uploaded in, posted at Perl.com. So I'm just going to quickly go over those to give you an idea of the kind of stuff that is possible. So in this article, he talks about using Facebook Graph to provide Facebook authentication for your website. So in essence, the first thing you need to do is go to Facebook, create an account if you don't have one. There's still a few people that don't have a Facebook account. And register your application. Okay? By registering your application, you're going to get an application ID, an application secret, which is 2 pieces of data that you need in order to use Facebook Graph. So in here, he has a dancer application that basically allows you to use Facebook to log into your website. And what it basically does is it requests a token on behalf of the user. And that access token allows you to make calls on behalf of the user to get data from Facebook or post stuff to Facebook. So pretty nice tutorial. Check it out if you need to. He has a follow-up example in which he describes how to post to people's wall using Facebook Graph. So check it out. It's in Perl.com in the archive for April of 2011. Okay, so back to the presentation. Okay, so okay, so basically the integration that we did at Ticketmaster has two main components. One is the RSVP module that can show up in multiple pages. Additionally, we have SIG tagging capabilities, which is a special case of RSVP. The difference, obviously, is that in an RSVP, you're just saying, hey, I'm attending this event, or I'm not attending, or maybe I'm going. When you're talking about SIG tagging, obviously, you're actually saying, hey, I'm going to this event, and I'm sitting here. So a SIG tag, in our case, also counts as an RSVP, but not the other way around. SIG tagging can be performed in a couple of places. One is the event details page. And the reason for this is that and we'll see it in a minute, is that that's where the actual map is shown, where the user can select where they're sitting. Also, in the confirmation page, after you make your purchase, if you didn't, for example, if you didn't do it in the event detail page, you can do it in the confirmation page. Or after you make your purchase, you can go back to the event detail page and mark what seats you bought and tag your friends and whatnot. So let's take a look at this, see what I'm talking about. Okay, so this is the Ticketmaster homepage. And here on the right, this is the RSVP module. And as you can see, it has the most popular events for the area that you are localized to. So these are all Wisconsin venues. And you can see that 498 people have RSVP to this particular event. If I actually had any friends here that are connected to Facebook and they're sharing their information, they will be shown in this tab here. So this is what it looks like in the homepage. When we go to an artist page, which is a little different because obviously it's going to show up stuff about events for a particular artist. So in this case, it's the Foo Fighters. And here you can see that it's asking me to RSVP to the event, and it's showing me a list of the people that are attending that particular event. Again, if I had any friends that are going to this, they'll show up here. You can browse who's going there. Now, one thing I wanted to mention, make sure that it's clear. All these people share chose to share the information with everybody, which means it's public. It's available for anybody to see. You can also share your information with just your friends. So if you want just that close group to be able to see if you're going and whatnot, only they will be able to see it. Okay. Okay. So I talked about the homepage. I talked about the artist page. There are a few other cases. You have the venue page, in which we list all the events that occur at that particular venue, all the upcoming events occurring at that particular venue. Section page, for example, if I go to sports, you'll see there's also an RSVP module here that allows you to see, who's going and if your friends are going. So obviously, each of these modules are pulling data from different places, and the amount of data that needs to be crunched to display it, varies from city to city, event to event, etc. But obviously, it's not something that we want to do on every request of this page. We just don't crunch this data and pull it up and show it. We try to save ourselves from doing that. Now, I'm going to talk about that later. So, okay, finally, this is an event detail page for an event occurring at the Fox Cities PAC. And I picked this event just because it had a map. Not all of our Ticketmaster events have maps. So in this particular case, you see a map of the venue with, the different seats are shown. And on this side here, we have the Facebook module in the ADP. Again, it allows you to see, filter by people sharing with everyone, your friends only, and so on. You can see the sections that have Facebook users are marked with a Facebook flag, and then you can drill down into them and see the people are actually tagged to those seats.
So can you see this before they actually purchase your tickets, or is it?
Well, in theory, if you are tagging yourself to a seat, that means you own those tickets. Okay.
I was saying because it would seem much more useful if you could see where your friends were sitting before you purchased the ticket versus.
Yeah, absolutely. So again, I haven't purchased tickets for this event, and if there were any of my friends that were going to this event and they were, and they tagged themselves to this map, I could come here, filter by friends, and I would see them listed here. Obviously, I don't have any here, so, but I can see those that are sharing with everybody. And it's basically the same functionality, right? If you hover over these names, you can see it tells you the section, row, seat, where they're sitting, and so on. So your question reminded me of a point that I should make, is that normally, so a lot of people buy their tickets on Ticketmaster.com, right? But sometimes people buy the tickets outside of Ticketmaster, right? They'll buy them from a friend or some other website. And basically, our application allows them to still come here and tag themselves. I can basically come and tag myself to any of the seats that are already sold. Sold seats are marked as gray. Now, if after that turns out that seat doesn't belong to me, the owner can come and basically put whoever he wants in that seat. But in this case, let's assume that I bought these tickets. I can come here and tag myself to a seat and choose with whom I'm going to share it. So I can share it with everybody, my friends, and no one. In the case of a purchase, though, the experience is a little different because I have multiple seats at my disposal. It's not just me tagging myself to one seat, but I have potentially multiple seats that I can tag myself to, or I can tag my friends to. So the way it works is when I come to the event detail page, a dialog will pop up that will show me all the seats that I bought. I have to be logged into Ticketmaster, of course, to be able to do that. A dialog will pop up in which allows me to tag any of my friends or myself to the seats I own. And that will translate in a post to my friend's Facebook page, and from there they can either accept or deny that tag. So if they don't want to participate, basically it's up to them. Okay. So this is pretty much the application. This module here on the left is all JavaScript code and HTML. The map itself is a Flash application that communicates back and forth with our JavaScript code to display what needs to be shown here. And some of the dialogues you see here, are invoked by the Flash widget to be displayed and so on. Okay, so that's pretty much that's what it looks like. So let's continue then. Okay, so this is a 50,000 feet view of what our application looks like. Okay, so you have the seat tagging code and the RSVP code, which, by the way, this RSVPs have nothing to do with the actual Facebook RSVPs. Facebook has a concept of events that you can RSVP to, and we hook into that. But the RSVPs that I'm talking about here are the ones that are made on the Ticketmaster side. Okay, so basically, this is what it looks like, right? And we have our seat tagging code connects to the Facebook Graph client that we built, and to perform calls like, okay, get me information about this user, get me information about the user's friends, and so on. The only information that we pull from Facebook are things like your name, your picture, and so on. So any requests that goes out to Facebook goes through our queuing system, which allows us to basically turn a synchronous request to Facebook into an asynchronous request, so that the UI is not blocked on waiting for stuff from the third party. Okay, we store the actual tags in the database. We don't store any Facebook information in our database, other than just the ID. Obviously, when we going out to Facebook to get stuff, we consider that an expensive operation, and we want to cache results of these calls. So we go to Facebook Graph, we request data, we put it in cache. If a user is tagging themselves, we store that in the database. And basically, the same thing applies for the RSVP module. We go to Facebook to get data, so we can display, okay, are any of your friends going? And who are your friends? So you can select, in the case of tagging, for example, when we display the dialog that allows you to associate one of your friends to a seat, we need to know who your friends are. So we need to go to Facebook and pull that data for you. So again, this is the very high-level view of the integration. Okay, so what are the problems? So I briefly touched on some of this already. I'll be going into more details. But in essence, talking to third parties can be slow. We need to retrieve, process, and aggregate lots of data. And another complication we have is that the information shown really depends on the viewing user, right? My friends are not necessarily the same as your friends, and anything that is shown on a page is really your view of that state. It's not, it's not shared, it's for you only, right? So before I continue here, I wanted to give you guys a warning. This is from the scene in Apollo 13 in which, Houston, we got a problem, and the guys in Houston basically need to figure out how to fix it with a certain set of tools. So I know that in our case, there are probably better tools we could have used to perform our integration, but we were limited to a certain number of things, and that's how we did it. It's, in a way, those constraints made it a little bit more interesting. So, okay. Talking to third parties can be slow. So how do we solve this? We place all the requests going to a third party, in this case Facebook, in our queue system. Our queue system have dedicated processes that perform synchronous requests on behalf of the application. And then the application can later come and check for the status of our request, and if we have the answer, then it will retrieve the results. Otherwise, it will repeat that process later. Obviously, you want to cache as much as you can. You don't want to be having to go out each time you want to retrieve this information. So cache as much as you can. And you'll see this in several slides. Okay. So, okay. Obviously, there's a need to retrieve lots of data. And a lot of the data, like I mentioned before, is very specific to the viewing user. So, in our case, for example, when we are, in the case of the event detail page, where we have several hundred users sharing their information, and we need to go out to Facebook and pull information about those users, their profile, URL, the picture, the name, and so on, so we can display the pictures and names and stuff. That information is specific to the events, right? And let's say that, let me show you something. Right, so we pull this information from Facebook, and in this case, I don't know how many there are here, but maybe, I don't know, maybe a couple dozen or so. So we need to be able to be a little smart about this. And when we go to the database and see, okay, so there are 400 users that are tagged to this particular event, and we need to go and get the data from them in Facebook. We don't actually try to request information for users we already have. So what we do is, that we have in cache. So what we do is, we figure out the delta, okay, so what do we have in cache, what users we don't know about, and then we'll make the request to get the data of the users we don't know about. And then we'll update the information in cache so that next time we don't have to, so we don't have to go again to Facebook and pull out that data. So figuring out the deltas so that you request smaller amounts of data from them. Okay. From the application side, don't transfer data if you don't need to. So basically, when a user, when the browser makes a request to our backend to retrieve information, it does it. It provides a value in the ETAG header, which basically it's a version number. So what we do is we compare that to the data we have for the event, and if the versions don't match, then you know that there's fresher data. So you'll pull that information up. But if it's the same, then the communication ends there. There's no need to exchange any more data. So again, also when you're talking about either pulling data from Facebook or going to the database, you cache as much of that data as you can. So that's that. Okay. Next step is we need to process and aggregate lots of data. So certain data needs to be fresher than some other data. For example, when we go to the home page, that displays, for example, RSVPs about all the events that are occurring in that particular region, right? So because it aggregates data from lots of events, it can potentially change with high frequency, more so than one particular event by itself. So when we retrieve and process this data, what we do is we actually store it in the database so that we don't have to recalculate it every time. And again, a lot of this information is cached as well, so we don't even have to hit the database if we don't have to. Another important thing that we do is make sure that everyone doesn't process the same data at the same time. And what I mean by this is when you're going to, for example, there are a lot of people going to the home page, right? And we don't want all of those users to initiate a process to generate the data that's going to be used. So what we do is we implement semaphores so that only one process is in charge of generating this data, and the others just wait. And once the process that got a hold of the semaphore completes, then the other process can just pull the data from cache instead of having to go and generate themselves. So obviously this saves a lot of CPU time and I/O and so on. Again, cache as much data as you can. Okay, so this is the other big issue we had, and information that is shown actually depends on the viewer of a particular page, right? So, like I mentioned before, I have different friends than you do, and we really don't want to. We don't want to generate a lot of data and push it to the clients and have the browsers process that data and just display what you need to see, right? Because that would create a privacy issue. I don't need to know who your friends are or who somebody that I don't know who their friends are and so on. So what you get is really information about either people that desire to share their information with everybody, which basically grants you permission to view it, or you and your friends, right? So by creating that separation of data, it allows you to cache it more in a smarter way. And what I mean by this is when a user looks at an event detail page and sees the map, right, and they see a list of all the users that are tagged to that event that are sharing with everybody, and then they switch to their friends. What a user really cares about is not so much about the people that are sharing with everybody, but they care to see their friends' information, right? So by separating, by partitioning the data into people that are sharing with everybody and people that are your friends, you're able to save yourself from having to calculate and process the data of the people that are in the bucket of everybody all the time. So, and also that data doesn't need to be as fresh as the information about you and your friends. So in the bucket of people sharing with everybody, which can be you, by the way, you can be sharing with everybody, that data is cached for longer periods of time. So let's say there are, I don't know, 1,000 users tagged to a map, and 500 of them are sharing with everybody. Those 500 are going to be cached for a period of time that is much larger than the information about you and your friends. So, and the way it works is the information about everybody basically is you overlap on top of it information about you and your friends. But they are partitioned that way, and they're cached separately, so you can have fresher data and more current data on the data that you actually care about. The other thing you can do is befriend your DBAs, and I'll show you why that is important in a minute. So, turns out that a query like the one you see here has a lot of limits, because there's actually there's a limit to the number of values you can put in a statement like this. Okay, so in this case we're using a relational database, right? And in order to get all the users that are tagged to a particular event, you need to run a query similar to this. But if there are lots of users, then they don't all fit into this in clause. So what we found out with the help of some of our senior engineers and DBAs was that we can actually use an Oracle temporary global table, which provides in-memory storage that is private for each connection. So what we do is first we insert the Facebook IDs of all your friends into this table, and then we make a join against the table that has the actual seed tags, and we can very quickly pull out all the tags that belong to you and your friends. This was a very interesting problem, and we're glad we were able to find a solution that helped us meet the requirements. So, yeah. Okay. And that's all I have. Do you guys have any questions?
How much of the Ticketmaster site is Perl?
So the question is how much of the Ticketmaster site is Perl, which doesn't have a lot to do with the presentation, but all the application right now that powers the website itself is a mod Perl application. Yeah. So basically, all the pages that you see in Ticketmaster.com, except the static ones, are generated by a mod Perl application. Yeah.
You mentioned speed being an issue, especially like querying and waiting for data to come back from Facebook.
Mm-hmm.
From the database side, are there speed issues with your keys or indexing?
So the question was if there were any speed issues related to keys and indexing on the database side. And yeah, the answer is not really. We're using Oracle to store this this information, and it actually, it can handle millions and millions of records really well. So as long as you have your keys set up correctly in the database and you have indexes in them, it works just fine. Yeah.
You said you do aggressive caching, and it would make sense because your friend list really doesn't change very often. Do you have anything in place, though, to periodic? Because it is possible someone could add a friend. Do you have anything to chase periodically?
Right. So we don't, but that's an action that basically invalidates cache. So any information that's about you or your friends would basically go out and make sure that will give you information about the tags, right? I'm not talking about your friends. If suddenly a friend of yours is not your friend anymore, but you tagged him, well, that's in the database. So that relationship is still there, but maybe if your friend changes their profile picture, you won't see it immediately because data about your friend is in cache and it's going to be there for a little bit. But information about the tags themselves, in the case of you and your friends, you always see the most up-to-date information. Yeah. Anything else?
So you said that you use this queue to change synchronous requests into asynchronous ones. I assume that's so that the page can go ahead and render in the web browser. How do you, when those jobs complete, how do you get that data back to the web page, or do you just populate the cache and wait for the next request to?
Yeah. When the front end, the UI basically needs to, it gets handed out a token that allows it to go back and check later for the status of that request. So some of those tokens are internal to our application. Some of them make it all the way to the UI. Yeah. Anybody else? That's it. All right. Thank you so much. And here are some references to the Facebook documentation, both articles that I mentioned about Facebook Graph that J.T. Smith did, and as well as a link to a success story. That's something I forgot to mention. This was definitely a success story for us. Each tag that you share on Facebook basically translates into, at the time of that this article was written, to $6 for Ticketmaster, because that causes people to, they want to try to buy tickets to the events that their friends are going. So, and they can also go and, because of the map, they can go and try to find tickets next to their friends. So, yeah, it's a very cool feature for us.
Do you make hosts to people's pages so this person's content can
Yeah, we can do that. But they have to, the user has to give the okay for that. Yeah.
So the basic is you just download the picture and the name with the next advance to accept this action posted on the wall.
Right. Yep. Cool. Thank you.